Hello students, welcome to your Chapter 9 review video. In this video, because we're at the end of Chapter 9, we're all finished with everything that we're going to do in this class with quadratic equations. I'm going to take just a couple minutes and sort of go through back to the beginning of Chapter 9, the types of things that we've done with quadratic equations, and just sort of briefly go over an example from each section. And hopefully this sort of informs your studying, so you can see sort of what you know, what you're good on, and if there's anything in here that you don't understand, then that's your cue to reach out to me and ask a question or do extra practice, look back over your notes, and things like that. So to start with, we did a Chapter 9 intro video that sort of encompassed the first two sections. We just briefly talked about what the graph of a quadratic equation looks like. So just as a refresher, a graph of a quadratic equation is what we call a parabola. And a parabola is basically a U-shaped graph, that looks something like this. Right, this is called a parabola. Parabola. Okay, parabola. That's the graph of a quadratic equation. That's what they all look like. Now, I'm not going to ask you to do anything in terms of graphing a quadratic equation. All I'm going to ask you to do is understand how the graphs are then related to the number of solutions that a quadratic equation has. Okay, so for example, if I graph a quadratic equation here in red, if it starts maybe down here, it goes up like that, and it goes up like that, okay? So this red graph here, I can even get rid of the other one if you want. So this red graph, this quadratic equation, has two solutions, right? Because we can see two places where this quadratic equation crosses over the x-axis. So the key thing to remember, and the only thing that I really care about you remembering from this section, is the idea that x-intercepts, meaning where the graph crosses the x-axis, are solutions to the equation, okay? So obviously, if we have a graph that never crosses the the x-axis, something like this, if it starts there and goes up like that and up like that, if it starts up and goes up and never does cross this x-axis here, then those are the types of equations that have no solutions, okay? So the graphs of a quadratic equation always look like parabolas, and where they cross the x-axis, the horizontal axis, is the solutions to the quadratic equation, all right? So that's all we did with the graphs in this chapter. Now, then we jumped into solving the quadratic equations ourselves algebraically, okay? And we started by solving quadratic equations that did not have an x term, just an x squared term. And they were able to be solved just by undoing things, or what we call by finding square roots in the end, right? So an example would be something like this. Let's say 9x squared minus 16 is equal to 0. Okay, 9x squared minus 16 is equal to 0. This is one where I can undo what's happening to the x and find my solutions. I can add 16 to both sides and get 9x squared is equal to 16. I can divide away the 9. I can get that x squared is equal to 16 over 9. I'm going to leave that as a fraction because when I square root to get rid of that squared piece on the x, I can actually do the square root of the top and the bottom separately. Square root of 16 is 4. The square root of 9 is 3. And then whenever we take a square root, remember, we always end up with two different options. So when we are solving quadratic equations with square roots like this, if you ever take a square root, you have to include this positive or negative symbol in front of your answer, okay? Or you could write two separate solutions, x equals 4 over 3, x equals negative 4 over 3. This or this is the same thing, okay? So that was the first way that we solved quadratic equations. We got the x all by itself because it only showed up one time, remember, right? It only showed up one time. Now, when we had quadratic trinomials or quadratic equations that did have an x term, then we had to factor to solve quadratic equations, okay? And we looked mainly at two different versions, all right? One version was something like this, 3x squared plus 9x is equal to 0. The other version would be like x squared minus 8x plus 15 equals 0. So both of these quadratic equations are factorable, but they're factorable in different ways. So if you remember from back in chapter 8 when we were factoring quadratic equations, the number one first thing to always look for, and we did a whole special video just on this, was we have to look for a common factor before we try to do any other sort of factoring into parentheses, right? So if we look at this equation on the left, 3x squared plus 9x equals 0, we can factor out of 3x, and we end up with this left in the parentheses, right? Remember, factoring out means we're dividing each of the pieces by whatever the common factor is. So in this case, I divide 3 by 3 and x squared by x, and I get 1x. I divide 9 by 3 and x by x, and I just get 3. Okay, so then I have this. Okay, so this is one way that we can factor things. Always be on the lookout for, especially if there's only two pieces and the other one is a 0, make sure we look for common factors. And then this other equation can be factored, not that there is a common factor here, but this is the type of factoring that we did with what multiplies to be 15 and what adds up to be 8, specifically negative 8. Adds up to negative 8, multiplies to positive 15 would be a minus 5 and a minus 3. Right? So we have these different ways of factoring. Remember, in this version here, we could also potentially need the window method, but we also have the quadratic formula, which we'll talk about in a second, as a way to avoid the window method if you really don't like it. Now, once we have the quadratic equations factored, and of course equals to 0, right? That's always step number one. Get them equal to 0, then look for what we can factor. I use something called the zero product property. So remember, it should be somewhere in your notes. The zero product property says if I have two different things multiplied together, like in this case, a 3x and an x plus 3, if they're multiplied together and they equal 0, my two choices are either 3x is equal to 0 or x plus 3 is equal to 0, and that will lead me to my two possible solutions. Okay? Two possible solutions here. This one I get by dividing by 3. 0 divided by 3 is 0. This one I get by subtracting 3. Right? That goes away. 0 minus 3 is negative 3. So I have now two solutions. One is x equals 0, one is x equals negative 3 for this equation. And it comes from setting each piece equal to 0 and then solving, okay? Over here in this case, we do exactly the same thing because we have these two pieces, x minus 5 and x minus 3. Each of those is going to get set equal to 0. And we're going to end up with x equals 5 and x equals 3 just by adding 5 and adding 3 on each side, okay? So when we factor, remember that it's important to get the quadratic equation equal to 0 first, and it is for the quadratic formula as well. And then we always want to look for factoring out a greatest common factor, or factoring by what multiplies to this and adds to this, or possibly the window method if you like that, or not. Okay, and then the last way that we solved quadratic equations was using the quadratic formula. And in the section about the quadratic formula, we also talked about something called the discriminant. Okay, so just as a reminder, the discriminant, I believe is how you spell that, for a quadratic equation is b squared minus 4 times a times c. Right, these are times 4 times a times c. Okay, so that's the discriminant, and remember that our quadratic equations right now are in the form ax squared. So the a is in front of the x squared. the b is in front of the x, and the c is the number at the end, and then it has to equal 0. Right? So the discriminant of the quadratic equation, this formula, when we calculate the number of the discriminant of a quadratic equation, it tells us a couple of things, right? Number one, it tells us if the discriminant is 0, then there's one solution. If the discriminant is positive, I would say equals a positive number, then there's 2 solutions. Okay, and if the discriminant equals a negative number, then there is no real solution. Okay, so that's the first thing that it tells us. And remember, number 2, if the discriminant can be square rooted, right? If it comes out as a number that we know the square root of, then the equation can be factored. Right? So if the discriminant comes out to be, let's say, 49 or 64 or 9 or 16 or 25, right? Those numbers that we can square root, or 100 or 144 or 1 or anything like that, then we know the equation can be factored. Now, if it comes out that the equation can't be factored, then really the only way we have to solve the quadratic equation is to use the quadratic formula. And it uses the same a's, b's, and c's, and it uses the formula negative b plus or minus the square root of b squared minus 4 times a times c, all of that divided by 2 times a, right? So x is equal to this. So we find the solutions for x by plugging a, b, and c into that formula. For example, if we have 2x squared plus 5x minus 4. 2x squared plus 5x minus 4 equals 0. If I want to find the solutions, I would simply plug a, b, and c into this formula, okay? And it would say, let's see, the opposite of b would be negative 5, plus or minus the square root of 5 squared would be 25, minus 4 times 2 times negative 4, divided by 2 times 2 on the bottom, okay? So then we get negative 5 plus or minus 4 times 2 is 8. 8 times negative 4 is negative 32. So now it says 25 minus negative 32. So we'll add a positive and get 57. Square root of 57 divided by 4. Right, and then remember that the plus minus symbol in the middle of our formula here tells me that I really have 2 different equations happening. The square root of 57, by the way, is somewhere around 7.6. Okay, so I'm just going to call it about 7.6. So what I have is negative 5 plus 7.6 divided by 4. And I also have negative 5 minus 7.6 divided by 4. Okay, so then I just continue to do my math, find my solutions in decimal form, round it off to 1 or 2 decimal places, doesn't matter really to me. So that's sort of the most involved, but also the most universal way to solve a quadratic equation. Remember that the quadratic formula always works no matter what. Factoring doesn't always work. Square roots doesn't always work. But these are the tools that we have, okay? If any of them are unfamiliar to you, if any of them seem too difficult for you, do please reach out to me. Let me know. I'd be happy to help you re-explain, walk through some examples with you before we take our test. If not, make sure we do our review problems, do some other studying if any of this stuff needs to be refreshed, and then we will take our test, and best of luck. We'll talk to you soon.